Hello, Sankal, are you there?
Yes, sir. You're audible, sir.
Yeah, I think your voice is a little bit, just you need to raise your volume.
Is it loud enough, sir?
1 second. Yeah.
Audible, right?
Yeah.
All right, sir.
Yeah. No audible, no problem.
Okay, sir.
We'll wait for some 1 or 2 minutes, we'll start.
All right.
Yeah, good evening, all of you. I welcome all the participants to this AROHAN lecture series 13. Today we have an resource person from Coral Technologies, Mr. Sankal Pallur. Sankalp, on behalf of all the staff members and the students and all the officials of collegiate and directorate, I welcome you, Sankalp. Now, actually, I request you to please carry on with your presentation. Sankalp?
Yes, sir.
Yeah, you can share your screen and you can start.
Yes, sir. Thanks a lot, sir. I'll begin. Let me first share my screen.
Yeah.
Is my screen visible?
Yeah, visible. Make it full screen.
Yes, sir.
Yeah, it's clearly visible. You can continue.
Thanks a lot, sir.
Okay.
So the topic for today that I'm going to deliver is implementing complex digital systems on reconfigurable hardware. So we all understand from our engineering, like probably third semester, we are looking at digital systems, logic design course, and you have some awareness of what this reconfigurable hardware is, mostly on FPGA. So though the title is around complex digital system, in this half an hour session, it may not be possible to actually implement a complex digital system, but definitely I will make you aware that there is a way to, this possibility exists. So I want you to be excited that such a possibility exists. And we look at a simple design flow, okay? And at the end, I'll show, if time permits me, I'll show some implementation on the board. So let's go back to basics. What does the most complex digital circuit comprise of? So at the bottom, you will have logic gates and or not, or you're trying to implement some Boolean function, which is also implemented using logic gates. You have flip-flops, you can use that as memory element. So basically, you are going to have some sequential circuit in your complex digital circuit, or some logic gate, a combination of sequential circuit and combinational circuits. And then the third important element is the connectivity, so wires to connect them. So we want to have a system that is able to map our complex digital circuit to such all these things are able to be realized. So in complex digital circuit realization, there are going to be two flows. One is the ASIC flow and one is the FPGA flow. I want to take a step back and say everyone knows that FPGA is field programmable gate array and ASIC is application specific integrated circuit. So in the industry, in the ASIC industry, semiconductor industry, there will be two flows, ASIC and FPGA. When people are working in this flow, the end result is a device which is millions of devices. But here the end result need not be millions of devices, rather they are few in numbers. All right. So the flow remains exactly the same. I may be describing some flow later on, wherein you see something like, okay, I'm writing a VHDL code or Verilog code, then I do synthesis, implementation, all that. On both the sides, you'll be seeing that flow, but it's slightly in a different context. So what is the difference here is that even once you terminate into the flow into your hardware device, it is possible to reconfigure this to a different functionality. Whereas in ASIC, the millions of devices, millions of parts that you manufactured are all those application specific design that has been put on those devices. So you cannot make any changes later on. If any problem happened in the flow, millions of parts are wasted, there's a heavy loss. But here, you can reprogram it, or rather reconfigure it. The right word to use is reconfigure it. So we are going to explore this word a little more because our title says reconfigurable systems, right? So we are going to explore this word a little more. Let's step back to the time wherein an FPGA just around came into existence so that you understand what are the basic internal blocks inside a FPGA, the field programmable gate array. So you had a matrix like this. So this is also a semiconductor device where you see these gray blocks. They were called, or they are even rather now called CLBs, configurable logic blocks. And these are the wires. So basically, you are going to use your combinational circuit to be mapped into these configurable logic blocks. Even to some extent, to a great extent, the sequential circuits also get mapped to this configurable logic blocks. And to connect them, to connect the logic, we need the switch box. It is possible to implement different functionality in same FPGA by changing CLB contents. Though you might have configured this as an example, as an AND gate, maybe at a later point you want to program some other functionality into it, it's possible, thus making it reconfigurable. So what is there essentially inside this configurable logic block? The most important block inside this CLB is what is called as the lookup table. So we'll explore what is a lookup table. We look up how a simple AND gate can be implemented. So this is a truth table, as we all know. Am I still in the session? Am I audible? Can I get a feedback?
Yes, sir, you are audible, sir.
Okay. So let's say, though I have this complex, let's say the device is very complex. Okay, it has a lot of these CLB elements which can be programmed with reprogrammed with the very complex digital circuit. But my intention now for this conceptual discussion is I want only AND gate, a simple AND gate to be realized. How is it that I do? In the traditional CLB, the CLB that I showed you some time back with the gray blocks called CLB, what was inside is a lookup table a flip-flop and a multiplexer connected in this fashion. Okay, this is what is my CLB internal implementation. If I would want to implement it as an AND gate, we know the truth table of the AND gate. If I apply 0, 0, I need the output to be 0, 1, 1, the output to be 1. So in the lookup table, inside my CLB, these are the numbers to be loaded. Okay. And on the path, I do not need it to be registered. I need it rather to come out straight away. So I would configure the select input of mux as 0. Hence, if I give, for example, 0, 0 as input, this is selected and this comes here. Since 0 is selected, 0 goes out. So if you work out all the combinations, you will see that this particular CLB is indeed working as an AND gate. So we say the configuration bit sequence for this CLB to function as an AND gate is this 0, 0, 0, 1 followed by the 0. So you are configuring the lookup table and the mux. Suppose I want the AND gate to be registered, AND gate output to be registered. We may know that combinational circuits are susceptible to glitches, right? That can be overcome by actually registering the output. So if our intention is to register my AND gate output, this is the configuration sequence. I load in AND gate's output column and I want a flip-flop on its path. So I use the select input as 1. So the configuration bit sequence for this configuration is going to be 0, 0, 0, 1 followed by this 1. So I needed to make this 1. Now suppose my digital circuit is this. This is what I want to implement. I am not able to achieve this in a single CLB, the traditional CLB as I have showed you, which comprises of a LUT, flip-flop and a mux. So I will require 2 back-to-back CLBs in this order. This should be the connection. So this first CLB, I will load 0, 0, 0, 1 for AND gate functioning. And since I want to select the flip-flop, I will load 1 into this. Whereas XOR gate output column will be 0, 1, 1, 0. And I don't want the output to be registered. So I give select input 0. So the configuration bit sequence, if I want to realize this kind of a digital circuit, is going to be 0, 0, 0, 1, 1, 0, 1, 1, 0, 0. So this is called configuration bit sequence. But then from this CLB to the other CLB, what is happening here? I need to establish a connectivity. So in that context, I need to know what this switch box concept is. So this switch box exists over here. So let's suppose I want to connect this CLB and this CLB. How do I go about doing it? So assuming that a CLB is on top and a CLB is at the bottom, these are all pass transistors and I've numbered it as 1, 2, 3, 4, 5 and 6. So corresponding to that number, I'm giving the configuration sequence. If I want to connect a CLB on top with CLB at the bottom, as an example, pass transistor 1 needs to be turned on. So 0, 0, 0. Fifth transistor I'm making 1 and the last transistor off again. If I want to make an east to west connectivity, I want to make the third pass transistor on. So hence you see that pass transistor is on. If I want to make west to south connectivity, I have a CLB structure here and a CLB structure here. Then I need to make pass transistor 3 on and 5 on. So that's the bit sequence. So that is reconfiguration. And when I reconfigure a very complex digital circuit, we have seen AND gate, we have seen AND gate followed by a flip-flop, we've seen AND gate followed by a flip-flop followed by an XOR gate. You've seen a small sequence. When we come up with a huge complex digital circuit, each of these blocks, each of these switch boxes have to be configured. So when the configuration happens, it culminates into what is called a bit stream. So we generate a bit stream. This is a binary file which is going to have the bit stream in it, a long sequence of ones and zeros. In fact, that is going to configure the configurable elements in your FPGA. So with this background of the simplified FPGA, for a starter, starting off on FPGA on AMD Xilinx devices, you would look at the 7 series FPGA architecture. This is like the first step for anyone starting off on their FPGA journey with AMD Xilinx devices. We don't have 2 input LUT, rather we have 6 input LUT. So you can realize 6 input Boolean functions. So you know that this truth table is going to be having 64 entries, 2 power 6. So the output column will have 64 entries in it, and the lookup table is not a 2 input lookup table. Previously, 2 input lookup table had 4 entries. 6 input lookup table is going to have 2 power 6 entries in it. So if we were to compare in our 7 series modern AMD Xilinx device, what is there inside this particular CLB structure? We say that it is having 2 more structures inside it. It's called slice L, slice L, slice L, slice M. On the next slide, or rather here itself, I would say each slice, in this slice, I have 4 LUTs. Each LUT is 6 inputs. I have 8 flip-flop elements. Not previously, I had 1 lookup table and 1 flip-flop. That's all, and 1 mux. But rather here in the modern day Xilinx device, I'm going to have 4 6-input lookup tables, 8 flip-flops, and a bunch of multiplexers, not 1 multiplexers. I can say there are at least 3 multiplexers. And a carry logic, this is for implementing fast additions. So based on carry look ahead adder, this is the block over there. So inside a slice L, what you would be seeing is, my screen is visible. I'm audible. My screen is visible, right?
Yes, sir. Yes, sir.
Yeah.
Screen is visible and you are audible.
Okay, all right. So if you see the comparison of a CLB and an old FPGA, inside CLB of a modern FPGA, you have 2 slice Ls inside a CLB, and each slice L had 1, 2, 3, 4 lookup tables with 6 inputs, and you can see 3 multiplexers. This is what is called a carry look ahead adder or the carry chain, and you have 8 flip-flops. So with this, it is possible to implement any functionality, any digital circuit you can realize. Coming into slice M, the variation is, you see a whole bunch of lines, a little more number of lines here, right? Compared to this, the functionality is exactly the same, but you can also use this structure to implement some small memories. Since it's called slice M, you could implement some small memories in the lookup tables. They are called as distributed memories. So how many CLBs are available in our 7 series Xilinx family? So you have a whole range of devices in the 7 series, starting from the lower end of called Spartan 7, then Arctic 7, Kintex 7, Vertex 7, Zinc. So you can see inside this also there are variants, various part numbers in which proportionally, this is proportional to the amount of CLB, 6,000 to 100,000. You go to the next family, the number of CLBs increases, and over here it's kind of the maximum number of CLB. So this device is a little different. Zinc device is little different from all these devices. These are all pure FPGAs where you can realize digital circuits on FPGAs, whereas this Zinc has an FPGA part and it also has a separate processor part. It has what is called as the processing system and what is called as the PL system. All these Spartan 7, Arctic 7, Kintex 7, Vertex 7, they have only the PL part. PL is programmable logic part. which is the FPGA part. This has, in addition, a processor. So it could be preferred, this would be preferred to develop embedded systems as well. So other than CLB, what are the dedicated sources inside our 7 series FPGA? These are all 7 series FPGAs. So far we discussed only about CLBs, but other than CLB, there is something like DSP slices, which can be used to for all these functionality listed. You have something called the block RAM. You have high-speed serial transceivers. You have XADC blocks, which are used to monitor internal and external analog conditions. So if I put a block diagram of what is there in the relatively modern FPGA, the one for the starter, the person starting off FPGA, you have not only CLB, you have VRAM, you have DSP slices, you have serial transceivers, and these were present in the earlier olden FPGAs as well. These are the IO blocks to get data from external world and to send data to the external world. How to use the blocks within an FPGA to implement hardware? It's not that we are going to draw a complex digital circuit. If it's AND gate, maybe we could have drawn AND gate and try to do reconfiguration. It's a conceptual discussion, yes. But when the complexity becomes huge, we cannot sit and write on paper, these are the configuration bits. A tool has to come into existence that supports this reconfiguration or development of this configuration bits or the bit stream per se. We need to follow an FPGA design flow. And the first step in FPGA design flow is to write the VHDL code or to write a Verilog code, hardware descriptive language, using some kind of a text editor. So we look up a basic Vivado tool flow of how a digital circuit can be realized on the FPGA device. So let us suppose our spec is to realize a 6-input AND gate. I've used a VHDL code wherein I've used Y is a signal. So this is a signal assignment operator. This is the bitwise AND operator. So this is what is expected to be realized. The entity name is AND61. It has 6 inputs and it has Y outputs. This is how the entity is written. And the architectural description, this is a data flow statement. Straightforward. This is the functionality. Now, how do I map this to my device, the FPGA device? So I need to follow this flow. The first step in this flow is what is VHDL design file entry. Any HDL, you can use VHDL or Verilog. On top of this, you will check whether functionally it is correct or not. For the functional correctness, you would depend on something called behavioral simulation. You will check the behavior of the RTL is correct or not. Functional correctness is verified at this step. Internally, the tool is going to do a design elaboration, which is nothing but mapping your code, VHDL code, to something that looks like gates, a gate level description. Like if I've written a 6-input AND gate, I'm expecting, I may not get something that looks like gates basically. If the internal library of the design elaboration does not have 6-input AND gate, it has 2-input AND gates, then your 6-input AND gate, what you wrote in the code, is realized using multiple 2-input AND gates. Then you do what is called a synthesis, which is you remember that you do not have AND gates, in your FPGA device. Rather, you have CLBs and LUTs. So this synthesis is a step of mapping the gate level netlist to resources. What are the resources available in my FPGA? How many LUTs are needed to realize and the connection between them. So understand that actually on the device, no placement or routing has happened. So we just have a synthesized netlist at this point. So on this netlist, we can run post-synthesis simulation. And after implementation, you will obtain a routed, placed and routed database. So you have an implemented netlist. On top of the implemented netlist, you can do a post-implementation simulation. And after you are happy that this is working, if you're following the flow in the correct manner, then you can do the bit stream generation. So after having verified the behavior of your RTL and taken it through design elaboration, synthesis, and implementation, the last step is bit stream generation. So the bit file will be generated, and we use something called a hardware manager to configure or rather reconfigure our FPGA device. So why this pin constraint here? Because let us say on the board, we have some dip switches. Dip switches are going to get connected to particular pins on my FPGA device. So that information I need to specify in a pin constraint file, or rather using a GUI after design elaboration. Let's look at the tool snapshots. So first, I have a design entry. I write a VHDL code or a Verilog code. Then I do a behavioral simulation and verify the correctness. These are tool snapshots. Upon opening the design elaborated schematic for a 6-input AND gate, it is implemented like this using 2-input AND gates. We will not see a 6-input AND gate because internally in the library, they don't have a 6-input AND gate straight away. So it's just representative. After synthesis, if you observe, this entire functionality of this AND gate is realized using a 6-input LUT, because this AND gate is a 6-input AND gate. So its output column, if this is A, B, C, D, E, F, and this is Y, the output column has 64 entries, all zeros, the last one is 1. It's stored here. So these are your input pins, how it is going to come into your device. It's indicative at this stage. They come through an input buffer, and before going to the outside world, it is sent through an output buffer. After implementation, the tool has decided to place the 6-input AND gate LUT over here, and these are all the input pins, and this is the output pin that will eventually be connected to LED. See, if you see here, these may represent dip switches. You may turn it on and off, and this could be connected to LED on the board. You can visualize this as your FPGA sitting on top of a board. So on the board, external to the FPGA, outside the FPGA, there are dip switches and LEDs. So if I zoom in on the implemented part, it looks like this: 6 inputs and a single output. So we will quickly look at, I think I have 5 minutes to complete my slot. So we'll look at a tool flow. So this is our Vivado 2023.1. I will give an example of a counter, okay, how counter can be realized. So I'll create a project. Let me call it counter. It already exists. 4-bit counter. So I will not specify my Verilog file at this time, but a little later after this point. I will select the board that I have, which is my Z board. So Z board houses the Zinc 7000 device, which I mentioned some time ago in that tabular column, which had Spartan, Artix, Vertex, right? The last one was Zinc. So it has both a PS and PL part. You can use this device for building embedded systems as well. So remember, the first step was to create a VHDL file or a Verilog file. So I'll say add or create design source, create file. I'll say counter, 4-bit counter, finish. Due to lack of time, I will not type the code, rather I'll just paste it. So this is my, if you observe this is code for a simple 4-bit counter. Open the file. I'm going to paste it. This is the first part, first step. The next step is to look at the behavioral simulation. So run behavioral simulation and verify whether it is working or not. So I'll set the clock to some frequency, force clock. So the time period of the clock is 100 nanoseconds. It has a duty cycle of 50%. Initially, I make reset as 1 so that my output of the counter becomes 0. So it's become 0 at this clock edge. So this is based on a synchronous reset. If you observe, this is synchronous reset. On the positive edge of the clock, if I see reset high, then output is 0. Now I'm going to deactivate reset. Make it 0. With every run, and I just want to show you the rollover happening. So the rollover happened. So I have verified the functionality, functional correctness. The behavioral simulation is fine. So we go ahead, we can close this simulation and we can open the elaborated design and see what is there in the elaborated design. This takes a moment. So at this point, you will not see any FPGA resources. You will not see LUTs. Rather, this will be gate level. Give it a minute. So it is representing it like this. It needs some kind of an adder. It needs all these flip-flops in it. 4 flip-flops are needed. This information is given as a gate level netlist. So because of lack of time, I'm going to open a complete.
Yeah. Can you just conclude, Sankalp?
Yes, sir. I'll conclude. So what happens is, I need to run synthesis. So after synthesis, I'm going to see the synthesized netlist. Then I can open the simulation. I can run a post-synthesis timing simulation. Then I can run implementation. Then I will be able to see the post-implementation timing simulation. I can verify on the waveform just like I did for behavioral simulation. All right. And after you have verified that implementation is fine, then you hit on generate bitstream. Once bitstream generation is over, then you would open hardware manager and you will observe the output on your board. So already the project is done. So I'll just try to demonstrate a working project where the counter is counting up at 1 hertz. Like 1 second, it is going on and off. Just 1 minute only, 1 more minute. So assuming that this is a little more complex project, not a simple counter, because in this project, I needed to create 1 Hertz clock. So all that is done in the background. So I won't be showing that. I will open hardware manager. Bitstream generation has been completed. I connect it to my board. And I say program device. Now, if you observe, you'll see the bit file. This is the bitstream file that we are talking about, the bit configuration. I say program. So programming the device. Now the counting has started. So I will just turn on the camera and I will conclude my session. So 1, 2, 3, 4, and it'll roll over. Okay. So I will close my session, and this is the Z board which can be used to implement all these projects as well as more complex digital circuits. In addition to that, you can have the embedded system development also happen on this particular device called the Zinc device, which is sitting on top of the Z board. So for more queries, you can contact Mr. Bhanu Prakash Dikshit at this number for any other training queries. If there are any question answers, if we have at this point, if I can take, I'm ready to take it. Or we can close the session and the next person can take over.
Any questions from audience, sir? I don't think any questions for you, Sankalp.
Okay, all right, sir.
Thank you very much for your wonderful session.
Yeah, thank you, sir.
And on behalf of all the stakeholders, I thank you for your time. Thank you very much. So we have
Thank you, sir. Thanks.
next resource person, Dr. Gnaneshwari, GR, and, from the Department of Computer Science and Engineering, Government Engineering College, Gangavati. Madam, are you there?
Yes, sir.
Yeah. You can start, sharing your presentation,
Yes,
and you can continue your session. Thank you.
sir. Is the screen visible, sir? Is the screen visible, sir?
Yeah, visible, not visible.
Yes, sir.
Yeah, you can continue.
Yes, sir. Thank you, sir. Good evening, one and all. Myself, Dr. Gnaneshwari GR at AROHAN 2024 with the topic of privacy preserving algorithms in pervasive computing algorithms. Before moving with the contents of my presentation, I would like to take few moments to thank and extend my sincere gratitude to our higher education department authorities, Department of Technical Education authorities for providing us the invaluable platform for sharing the best practices imparted at our college. This opportunity to present and exchange such ideas not only enhances our collaborative efforts, but also significantly contributes to our collective growth, progress, innovation, and success. Thank you for creating a space where creativity and technical expertise can thrive. Thank you on behalf of all our faculty members of all government engineering colleges, all government polytechnics, and students. A special thanks to AROHAN coordinator, Sir, Dr. T.G. Basraj, Sir, and the task force team for taking all the efforts to organize AROHAN. I would like to put limelight on the best practices inculcated at our college, Government Engineering College, Gangavati. We have the Red Cross Wing organized and successfully completed blood donation camp 2 times at our college along with the Red Cross Society, Koppala district. We have training and placement wing, which is responsible for having almost 12 MOUs signed with nearby industries and we have already sent 2 batches of engineering students out, with almost 42 students have got the offer letter and placed. The training and placement cell also provides the soft skills trainings. We have NSS wing at our college where the coordinators take our students to nearby schools, villages, colleges, historical places where they learn and also impart the knowledge, such as they help local students to achieve good results and enhance enrollments in higher education. We even do induction programs where we conduct programs for first year students to make them familiar with VTU academics and college environment. We also perform many other activities such as yoga activities, health awareness programs, universal human values or practices. We do mentoring students at our college, which has improved the result status of our college. And I would be proud to say that a student of our mechanical department from our college is being listed in top 100 students list of VTU website for securing good marks. All these activities help the staff and students of our college feel more socially responsible, confident, and connect to the society easily. Except 1 or 2, almost all activities are part of VTU curriculum. Hence, all the colleges are made to impart the best practices to follow in their academics. So even I would like to thank the authorities of VTU Belgaum for making all the colleges to practice such best practices in their college. Now, moving on to my actual topic presentation, the contents of the, I'm audible, sir? Am I audible? Can please anyone tell?
Yes, madam, you are audible.
Yes.
Continue, ma'am.
Yes. Coming to the actual topic of my presentation, the contents of the slide are introduction, principles of pervasive computing, evolution and related fields of pervasive computing, applications, challenges, attacks in pervasive computing, methods for privacy preserving. Introduction. Pervasive computing is also called as ubiquitous computing, which is the new trend towards embedding every object into the microprocessor. The word pervasive or ubiquitous means existing everywhere. Everywhere wherever the users are using the network. This environments aim to make computing available everywhere and at all times, often through a network of interconnected devices that work together. It spreads intelligence and connectivity to more or less everything. For example, ships, aircraft, stars, bridges, doors, even a coffee mug, and even the human body embedded with chips. So mobile internet access, third generation wireless communication handheld devices are making pervasive computing a reality. The principles of pervasive computing are decentralization, diversification, simplicity, and connectivity. As the name suggests, decentralization, there is no centralized system. The principle is that all the devices should be capable of computing at their individual locations at the distributed network. Diversification, pervasive computing should occur even on the smallest of devices to supply a few or at least one type of data point. That is, every devices such as laptops, mobiles, iPhone, smart watches, all should have the capability of computing. Connectivity, it enables devices to connect, synchronize in the manner when linked to infrastructure like internet, or even home or office network. Simplicity, the most crucial feature of pervasive computing is that devices should work even without acknowledging their existence. Evolution of pervasive computing started with the most scientist of America, who is termed as the father of pervasive computing, that is Mark Weiser, who said in his thought that the most profound technologies are those that disappear. That is, being with us, we feel they are disappeared. They weave themselves into the fabric of everyday life until they are indistinguishable from it. It started with the computing generation started with mainframe computers, where one computer and many people used to use that system. PCs were one person to person, that is second generation, and then ubiquitous computing, where one person have many computers. The pervasive computing is related with the fields of distributed system and mobile computing. The features of distributed system of remote communication, fault tolerance, high availability, remote information access, distributed system, together with the mobile computing features of mobile networking, mobile information access, adaptive applications, energy aware system. With this, some of the additional features of smart faces, invisibility, localized scalability, and uneven conditioning, all these features together make up pervasive computing environment. So it is the combination of distributed systems, mobile computing, along with additional features of smart spaces, invisibility, localized scalability, and uneven conditioning. Sometimes the pervasive computing is correlated with IoT, but I would like just to put a light on that, where IoT refers to the network of interconnected devices that communicate and share data over the internet. The same with pervasive computing, where it is human-computer interaction. IoT is device-to-device interaction, whereas pervasive computing is device-to-device and human interaction with it. Some of the applications of pervasive computing environment are healthcare domain, where a simple living room can be converted into healthcare unit with the help of smart wearable body sensors, which could monitor the patient's vital statistics such as heart rate, blood pressure, body temperature, glucose level, and so on. When coupled with telemonitoring, this healthcare facility can become extremely useful for those who are unattended, such as elderly persons or physically challenged persons. We have one more scenario of edible computers, the pill cam, which when inserted can get the entire diagnostic report of a human body. Application and industry domain, where a user can access mission critical data, contracts, technical descriptions, small database and graphics, etc. at any time and anywhere. Applications of transportation domain, where the pervasive computing allows navigation system to suggest, allocate parking slots, and assist in selecting hotels, restaurants during the travel. It can also automatically alert the nearest police station or vehicle service station or even hospitals during the time of accidents. Agriculture domain, wherein the pervasive system helps with the sensors to measure soil health, sense the atmospheric conditions, moisture, humidity, sunlight, and provide necessary information to cultivators to achieve high crop yield and reduce operational costs. Some of the challenges of pervasive computing environment are nothing but actually the features or characteristics of the pervasive computing environment. The expansion of computing boundaries. There is no limit to the boundaries of computing because the pervasive computing has the Mark Weiser said, it fabrics into the clothes of the users. Hence, there is no limit to the boundaries. It is just going, expanding every minute. Invisibility and unobstructiveness, that is, the devices are becoming more common and their maximum presence makes them invisibility. Creating smart spaces, every space is becoming smart, intelligent enough to generate the data and generate data. Lack of ownership, the devices are lacking the ownership, context dependency, amount of data collection, how much amount of data is going to be collected is limitless, and scalability. Actually, these are the main features or characteristics of pervasive computing environment, but which tends to be the challenges as they are growing limitless. So some of the attacks which are possible in pervasive computing are eavesdropping, that is unauthorized interception of communications between devices, data leakage, where unintentional or malicious release of private data to unauthorized parties, that is unauthorized persons can have the private data of a user. Location tracking, unauthorized tracking of a user location through devices with GPS or other location determining technologies. Device compromise, that is control of user devices is being taken by unauthorized access. Identity theft, theft of personal information to impersonate the user, often through phishing or social engineering. Replay attacks, where interception and retransmission of valid data transmissions to device, a system, or gain unauthorized access. Man-in-middle attacks, attack, intercepts, and potentially alters communication between two parties without their knowledge, session hijacking, taking over an active session between a user and a service, often by stealing session tokens or credentials. Side channel attacks, exploiting physical characteristics of a system to extract confidential information. Malware and spyware were malicious software designed to infiltrate and damage devices or spy on users and data. So there are many more attacks which can be accomplished on pervasive computing, but to name few I have taken. So this attacks leads to the which harms the privacy of a user. Why privacy matters? Why it is so important? Why the security or privacy of a user is important? Inevitably, we release a lot of personal information whenever we are browsing. All we may be aware, whenever we are browsing, we are shopping, we are doing any sort of activities on online, we inevitably give most of our personal information, whether it is related or unrelated. We just go on entering all the information asked by the browsers. This information may be improperly used, which may affect like respect for individuals, reputation management, limit on power, maintaining appropriate social boundaries, trust, freedom of thought and speech, social and political activities. So if at all our personal information is being improperly used, we may suffer with all these problems, because of which privacy is very important. So methods for privacy preserving are data anonymization, where anonymization and pseudonymization masks user identities by removing or altering personal identifiers in the data collected. Then encryption, the data both at the rest and in transit ensures that even if unauthorized access occurs, the data remains unintangible without the proper decryption keys. Access control, implementing robust access control mechanisms ensure that only authorized individuals or systems can access sensitive data. Differential privacy, this method introduced random noise, the data to prevent the identification of individuals from aggregate data. Secure multi-party computation allows multiple parties to jointly compute a function over their inputs without revealing their individual inputs. Homomorphic encryption, this allows computations to be performed on encrypted data without needing to decrypt it first. Privacy preserving data mining, where mining is being done on the data without exposing the sensitive individual data. Location privacy, here we see to it that the location is being shared less frequently or approximate location updates are given. Policy enforcement, we have to implement certain policies that ensures compliance through automated mechanisms or legal frameworks, which can help safeguard data usage and sharing practices. This is my PhD topic, but I outlined only few of the concepts or basic concepts of pervasive computing environment and the different methods of privacy preserving and attacks in privacy preserving. The topics or the methods which I have chosen for my PhD work was data anonymization, encryption, access control, and secure multi-party competition, where in secure multi-party competition, the data publishing was done jointly. That is collaboration of multiple datas, which reduced some part of privacy, and then data anonymization and pseudonymity, where the user identification is masked, encryption, where data is being hidden or data is being we cannot read or access the data without the decryption keys, and access control was one more method which was used. Totally, I made a combination of 4 different methods, and together I was able to achieve my doctorate. So these are the 2 papers, Q1 journal papers that are being published based on my 4 objectives, which were divided into 2 design phases. One was authentication based access control approach for enhancing security in pervasive computing environment, where we took a combination of authentication based access control, that is the user is being authenticated before accessing the data, and the access is also limited. The other one was the throw water wave optimization algorithm for privacy preserving collaborative data publishing, where we used 2 different algorithms. One is cross search algorithm and water wave optimization algorithm, where these 2 together we added the functionalities of K anonymity, L diversity, pseudonymity, all these functions. Together, we were able to merge up these 2 different combinations and get a better result. Conclusion: privacy preservation in pervasive computing environments is crucial to maintain user trust and data security in this increasingly connected world. As pervasive computing integrates seamlessly into daily life, it becomes essential to adopt robust privacy measures that protect sensitive information from unauthorized access and misuse. Effective privacy strategies should include advanced encryption, anonymization techniques, and strict access controls, while also considering the trade-off between functionality and privacy. All this were considered in my PhD topic. By prioritizing these measures, we can ensure that the benefits of pervasive computing do not come at the expense of user privacy, thus fostering a safer and more secure digital environment. Thank you, one and all.
Thank you, madam. Is there any questions from audience? Yeah. You can answer. Madam, GEC Gangavati.
Yes, sir.
Yes, sir. I have.
Yeah, good evening, sir. This is Professor Edison Gamai, principal lecturer here. Madam, there is no questions. Just I wanted to thank you for a very good presentation. In that, a impressive and interesting new technology being discussed. At the same time, thank you. As an in-charge principal, I thank you for highlighting the best practices which we are conducting at our college level. Thank you. All the very best. Thank you, sir.
Thank you, sir. Thank you.
Yeah, madam, it was a very nice informative session from you, and it went very, steadily, and you were able to demonstrate or describe your research work and the importance of perseverance perseverance computing. So on behalf of all the officials of higher education, as well as all the staff members who are here and students, I thank you all really for sharing your knowledge on this platform. Thank you very much, ma'am.
Thank you, sir. Thank you, sir.
Yeah. Now we have a next speaker, Dr. Gauri Shankar. Hello.
Hello, sir.
Yeah. Just I welcome you to this AROHAN session.
Thank you very much, sir.
Yeah, it's my pleasure to introduce you. One second. Just. Yeah, Dr. Gauri Shankar is currently working as a professor in the Department of Computer Science and Engineering at Dr. Ambedkar Institute of Technology, Bangalore, Karnataka. He earned his MBA in Marketing Management from Indira Gandhi National Open University, IGNOU, New Delhi, in 2020, and PhD Engineering from Faculty of Engineering and Technology, Jadavpur University, Kolkata, in 2010. And he has MTech from GEC Mysore in Software Engineering in 2005, and BE from VTU Bangalore in 2003. And from 2011 to 14, he was at Annual Technology Bangalore, as I was working as he was a senior research scientist and technical lead, and he has published several papers in various reputed international and national conferences, and he is serving as an editor and reviewer for various prestigious journals, and he has delivered many keynote addresses and innovative talks throughout India and Bharat on a variety of topics related to computer science and engineering. He has also served on the panel of a number of academic bodies of universities and autonomous colleges as a BOS and BOE member. His current research efforts are mainly focused on applications and implications of machine learning, deep learning, and data analytics for upliftment of society. It's a pleasure to have you on this platform, Gauri Shankar.
Thank you very much, sir.
On behalf of all the audience and officials of DTE, I welcome to deliver this session. So you can share your slides if you have, and you can start presenting. Thank you.
Yes, sir. Sir, is the screen visible?
Yeah, visible.
Okay. Good evening to all, and thank you very much, sir. And today, my talk is on foundation of polars for data analytics. So, as sir said, I am working as professor in the Department of Computer Science and Engineering at Dr. Ambedkar Institute of Technology at Bangalore. I have 10 plus teaching experience and 3.6 years of industry experience, and I'm mainly into machine learning, deep learning, and data analytics. So that is my domain. And the flow of this session, so this is what I will be doing today. So we'll be having a cursory look at data analytics stacks in Python for 5 minutes. I will discuss the data analytics stack, and then I will talk about something called polars package. So this is the library that is a hot library, I can say, that is happening in the data analytics world in the Python ecosystem. So I'll be talking about this polars for 15 minutes, and I will also show how this polars can be used for generating the charts using the Plotly library, and this for 5 minutes. And I can have question and answer session for 5 minutes at the end. And this is how my session will be flowing through. Okay, so getting back to the today's topic, before that, I would just want to quote this particular tweet from Jake Vanderplas. So if you are wondering who is Jake Vanderplas, so he's a big shot in data science and data analytics world. So he has written a book which is something called as a hands-on data science book, and he has developed various kind of software that has been used throughout the world. So he's a big shot in data analytics world as well as Python ecosystem is concerned. So this is what he has said. The truth about data science: cleaning your data is 90% of the work, fitting the model is easy, interpreting the results is the other 90%. So here there are two concepts which we have to understand. One is the data analytics, the cleaning of data and how to interpret it, and how to show it to the other person. So this is the majority of the work where the work is carried on. 90% of the work is all about cleaning the data and interpreting the data. So now, if you are thinking why I have chosen this particular nitty-gritty area, the reason is, see, data analytics is the one, that's the basic step or the foundation on which the other stuff can be built. Say, for example, if you want to apply machine learning, again, you have to clean up the data. You have to make sure that data is fit for analyzing the for analysis purpose. Again, if you want to use it for PyTorch library or for deep learning analysis. So all of these need the data to be representable and the data is cleaned up. So most of the time, even as a data scientist, as a data engineer, you will be working on cleaning up the data and interpreting the data and how the data is like. So now let's understand what is this data analytics. So if you ask what is this data analytics and the definition for data analytics, all I can say is, so just take the data, compile it and analyze the data. So that is the kind of definition that helps for a layman. And let's get a little bit deep into to understand what is this data analytics. So say, for example, you have a problem, you form some hypothesis, and you design some experiment, and because of that experiment, some data gets generated and you'll collect that data. So once you have the data in your hand, what next? So the next step is you need to import that data into the software. And once you have done that, there is no guarantee that the data that gets generated is in a proper format. So usually what happens is, say, for example, whenever you do some kind of shopping, so the data gets generated. The data that I enter need not be the same generic data the other person enters. So I may skip some of the fields and the other person may skip some of the fields. And sometimes instead of giving the data in one format, say for example, so if we take the Indian date system, so the first part is like day, and then we'll have month, and then we'll have the year. But if you go to the US system, it is like month, day, and the year. So there is difference in how the data has to be interpreted. So that data has to be put in a form so that it can be used. And the next is, again, you have to explore or test the data. And once you have explored, you need to transform the data. Transform in the sense, so we need to make sure that the data that we have in our hand is something that can be applied for the next library. Say, for example, machine learning library or deep learning library or any other library that needs further analysis. And then you need to write a code to apply a modeling algorithm so you can model something out of the data. And then finally, you will visualize the data. So once you have visualized the data, what next? So after visualizing data, you have to communicate the results. So you can't keep it for yourself. So you need to give it to your boss or to your management so that they can do some informed decision about that. So how to do that? So how to communicate the results? So you have two ways. One is you can build an app so that the other management or the boss, he can just download that app and then he can surf through the data and understand through charts. Or otherwise, you can write a paper, a white paper or a technical paper, and then you can communicate that paper to your audience. So that is one way. So now there are so many steps which we discussed here. Which steps are relevant for the data analytics? So here, the boxes that I have marked in green, so they are part of core data analytics. So they form the part of data analytics. The other things, yes, we need, but they are not that relevant. So let me take out only those stuff that are in the green blocks, and then let me just shuffle in a way that others can understand it. So let me put it and shuffle it in this way. So import data into software, tidy the data into usable form, visualize the data, and transform the data to do some feature engineering, write the code to model the algorithm, and whatever the results that you get, build an app or write a paper or publish a paper or deploy an app. So in general, so this is how a data analytics work. That is import, tidy, and then you can transform, visualize, model, and then whatever the results you get, you need to communicate. This is how data analytics work. And now my main part is this tidy and transformation. So this is where the library which I will be discussing plays a major role. So I will be tidying up the data, and then I'll be transforming the data so that it can be modeled, it can be visualized, and then it can be communicated. So, okay, so this is the summary of data analytics: import, tidy, transform, visualize, model, and then finally you communicate. So now if you ask, so in the Python data science ecosystem, in that stack, what are the kind of libraries that you can look at? So basically we have this Python library upon which we have various other libraries that have been built, like NumPy, Jupyter's, and we have this IDE called Spider. And again, on top of that, we have SciPy. So if you want to do any of these statistics, you can use for a scientific purpose, you can use SciPy. And then you have this something called Pandas. So as of now, the #1 library in Python ecosystem is Pandas for doing data analytics. And for visualization purpose, the #1 library is Matplotlib. But people are exploring other libraries as well, which will give them much more value to the effort they put. And on top of all of these libraries, we have very big libraries, some for doing machine learning stuff and deep learning stuff, something called, so we have the scikit-learn. So this is the library that we'll be using for doing machine learning in Python. And then we have the stats model for doing statistics. And then we have this Xarray and few other libraries which are built on top of SciPy. Okay, see, let me make it clear. If I want to do data analytics in Python world, then there is one top library which I have to use, that is Pandas. Okay, so this Pandas was created by a person called Wes McKinney, and he is a top guy when it comes to the data analytics world in Python ecosystem. So he has built two software. One is Pandas, and another one is something called as Arrow. Later on, I will explain what is this Arrow and what is its part in data analytics world. So before that, the person who created Pandas, which is used for data analytics in Python, so he has said that he hates 10 things about Python. Pandas. So what are those? So the first one is internals are too far from the metal. So it means the Pandas library, whatever the library that he himself had developed, so it is not making use of the CPU and GPU power in an optimum way. So the reason here is when he designed this Pandas software in 2008, specifically it was released in around 2009. So during that time, so GPU was not a hot topic like today. And they did not make use of the CPU cycle like other softwares that make use of today. So as of now, Pandas, it doesn't make use of CPU and GPU in an optimum way. And then the other problem is no support for memory mapped dataset. So when I say memory mapped dataset, so you have something called in-memory computation. Okay, so here when I say in-memory computation, so when whatever the RAM that I have, so that will be used for doing the computation purpose. So, but that is not supported by Pandas in a proper way. And then we have something called poor performance in database and file ingest and export. See, whenever we are doing this data analytics, so individually, if I say like if I am a sole developer, then I will be using some Excel sheet or CSV file wherein the data is present. But in real world, it doesn't work in that way. What happens is you have to extract the data from the database that's already there in the enterprise. So now, if you have a software that is not able to communicate with the database properly in an optimum way, then obviously it will have the performance hit on the entire software pipeline stack. And then again, it may lead to more energy consumption, more cycles of CPU, and in turn it results in more spending of money. So because of this, again, Pandas, it doesn't communicate properly with the database. And again, so it has this file ingest and export. So it is little bit bad, like it is not able to export the data in an optimum way. And missing data, doing the missing data, right? See, as I told you before, they are getting the data in a proper format. It's nearly impossible in the real world. So sometimes some of the fields will be missing, and sometimes some irrelevant data might be fed into the whatever the data that we were expecting. So now, what to do if the data is missing? So how to handle the missing data? So there are various techniques to handle the missing data, like you can fill the mean value of the entire column wherever the data is missing, and sometimes you can just pull the forward data and fill in the blank data, or you can just pull the data in the backward column and fill it in the current column. So there are different ways in which you can handle this missing data. But what happens if there are huge amount of missing data? How to handle that? This part, pandas is not able to do it properly, and there is no transparency in memory use and in RAM management. And pandas, as of now, it has little bit weak category support for categorical data. So when I say categorical data, it is more like the text data. So usually most of the data, it will be in text format, and it's a huge consumption of like it takes memory a lot to get the proper categorical data to analyze it properly. So pandas, it has having weak support for categorical data. And the group by operation, see, when I say group by operation, obviously we'll be doing some aggregation like minimum, maximum, average, if I want to find the median. So just imagine billions of rows, and for that billions of rows, I want to do the aggregation of that billions of column rows which we have. So when that is the situation, just imagine the amount of data that RAM that needs to be consumed to compute that. So here, pandas, so it doesn't have that kind of support for group by operations, and appending the data to the existing data frame, it is tedious and very costly, and it has limited and non-extensible type metadata. So usually what happens is, so I will be having, we do have various types of data types, right? Like integer, floats. So that is for normal day-to-day operations. But we are living in an internet world where there are different kinds of data types. Say, for example, even nowadays, even currency is a data type. And how to handle these kind of new types of data types? So that is not well supported in pandas. And there is no eager evaluation model in the previous version of pandas, but now they are introducing support in the pandas for eager evaluation, but still it is a work in progress. And then slow, limited multi-core algorithms for large data sets. So I'll be dealing with multi-core algorithms and how it is used in the later on time slide. So as of now, let's understand that in pandas, so the multi-core algorithms are not supported to the extent that it was expected. So I am not against pandas, but what I am trying to convey here is, when the author of the software, he himself is not happy with the kind of software that has been produced. So I believe that we need to check alternatives where it makes sense. And which is that alternative? So you have something called Polars. So this Polars library, it has taken the Python world by storm. So everyone nowadays, they are talking about the Polars. So what is this Polars? So he's the person behind the Polars. So he's a Richie Wink. So he's the creator of Polars. And now, if you ask, why should I use Polars or pandas for data analytics? One important word is performance. Okay, so when you compare the performance of Polars and pandas, so there is a huge difference the kind of performance the Polar has over pandas. So according to some test that has been carried out, so Polars is 5 to 10 times faster than pandas. And when it comes to consumption of the RAM, so say for example, if you want to work with 1 GB of data, then the amount of RAM pandas expects is like around 10 times, maybe like around 10 GB of RAM. But when it comes to Polars, it expects like 4 GB of RAM to analyze 1 GB of data. So 4 GB of RAM is more than enough. See, nowadays, most of our laptops, it is equipped like with 8 GB of RAM or 16 GB of RAM. So that's not a big deal, but still, the amount of data that gets generated. So people are talking in terms of TBs, terabytes. So when that is the case, obviously we need to look at like how the amount of RAM that is needed for carrying out the operations. So here Polars wins hands over these pandas. And not only pandas, so there are other data frames as well, data frame libraries. So when you compare the performance of Polars or those different data libraries, so Polars, it wins hands down. And you may ask, so will Polars never run out of memory? Yes, due to physical constraints, sometimes yes, Polars, it may run out of memory. So if that is the case, it will give you some memory errors, but this happens only when the memory is not sufficient. That's it. And in the previous slide, I just told that the reason why we have to choose Polars is about the performance. Now, if you ask, how did it get such a fast performance? How the performance is so impressive in Polars? The reason is the Polars library, even though it is a Python library, the core concept, so the core facts that it has been written in a programming language called Rust. Okay, so nowadays what is happening is almost all the libraries, they are being written in Rust, a programming language called Rust. And on top of that, they are giving bindings to Python. So it looks like Python library, but the core part is always written in Python, Rust programming language. On top of that, you will be given bindings so that you can make use of Python programming language to access the APIs that has been written in Rust. And what is this Rust? So one thing that another thing that I can add here is Rust is the only other programming language that has been permitted to be written or to program the kernel of Linux. So just imagine, for the past 40 years, none of the other programming languages were allowed except C and C++. None of the programming languages were used to develop the kernel of Linux. So now, if they have chosen and if they have given the permission to use Rust to develop the Linux kernel, then imagine the kind of the confidence people have in using this programming language. And the other problem when it comes to Pandas library is it's built on top of something called NumPy library. So NumPy is another library on top of which Pandas has been written. So, but in Polars, we do not have that kind of dependency. It has not been built on any of the other libraries. It is a standalone library, but it can make use of any other libraries. It is not built on top of any other library. It's a standalone library, Polars. But that's not the case with Pandas. And since Pandas has been built on top of NumPy, whatever the bugs, whatever the memory problems that NumPy has, it is automatically transferred to Pandas as well. So because of this, the performance of Pandas is poor in many of the cases. And then when it comes to Rust, if you ask why people are behind Rust, it is because of concurrency. And when I say concurrency, it is not just normal concurrency, it is safe concurrency. So it is guaranteed that concurrency is safe in Rust programming language. And the author of Polars, he has mentioned that Polars is embracingly parallel, because I myself have seen, so my laptop has 4 cores. And the moment I try to copy around like 1 or 2 GB of data from one data frame to another data frame, all the 4 cores, it will be running and it will be making the sound. So it shows that all the cores are being used by the Polars library. And another reason why Polars performance is better than Pandas is it is based on something called Apache Arrow. Okay, so it is based on Arrow specification. So Arrow, if you ask, it is both a software and a specification. It is both available as a software and a specification. So if you are interested in building something for interoperability, then you can use this specification and build your own software. So now see, previously the problem what was happening is there were different libraries for data analytics like Pandas, like Spark and Impala, Drill. So now the data that got generated in Pandas it was not compatible with another library like Spark. And the data that was getting generated in Spark, it was not compatible with Pandas. So what was the solution for this? There should be some type of interoperability between different types of data analytics software, right? So for that, they have come up with something called Apache Arrow. So Apache Arrow is the backend for Polars. And now even in Pandas 2.0 version, so they have made Apache Arrow as the backend, but it's not fully supported yet, but they are working towards that. So now if you ask why this Apache Arrow should be used other than for interoperability, see, most of the computation, it is because of interoperability. Okay, you can't work in with just with one library and say that you will do each and everything in one library. So you need to work across different pipelines, different software. So for that, if you do not have this arrow specification, then you have to serialize the data, and then when it comes across to the other software, then you have to deserialize, and this itself took a lot of amount for, and it consumed the memory. So it was not an efficient way of doing. So it was part of like all the computing costs were happening because of this serialization and deserialization. And Arrow memory is one which took care of this. And Arrow, it also support various different data types other than what Pandas support, like I said previously. So it has support for currency data type as well, like that. And finally, when it comes to Arrow, so the data, it is stored in a columnar format. So it is, the data is stored in columns, and all the columns are stored in continuous block of memory. So this not only makes parallelism easier, but also the data retrieval will be faster. And the query optimization in Pandas, you do not have lazy execution, but in Polars we have this lazy execution. So in Polars you can do both eager and lazy execution, but in Pandas it's only eager execution. You do not have lazy execution. Okay, so now if you ask what is this lazy execution, so here is what I say. Say for example, you want to do 2 or 3 tasks, task 1, task 2, and task 3. So now the problem here is how to handle these different tasks. So I will see what Polars does is it takes the result of task 1. So until then, task 2 will be waiting. It again takes the result, and again it takes the and it feeds that result to task 3. So the output that comes from one task is fed to the next task. Like this, once the data has been fed, then it starts to execute. That is known as lazy execution. Okay. So apart from this, Polars, it has something called expressive API. So this expressive API, so I will talk later when I show the actual code. So let's remember that as of now that there is something called expressive APIs in Polars. Okay. So until now I am bashing Pandas again and again. So if you ask, should I work with Pandas or should I completely jump to Polars? I say it all depends on your requirements. So since Pandas, it is from 2008, so most of the ecosystem, they are dependent on Pandas, and they do support Pandas very nicely, and it fits nicely with the data science ecosystem. But that doesn't mean that the other libraries do not support Polars. As you can see here, all the libraries that used to support Pandas, so the same libraries, they also do support Polars. So if you take GeoPandas or Plotly or DAS, Seaborn, Altair, so all of these different libraries, they do support Polars. It's not like Polars is in an island. So they do support Polars. So the Pandas ecosystem, they do support Polars, and you can use Polars software confidently with any of these libraries according to your requirements. So let me summarize the features of Polars here. So one is it is fast, obviously because it is written from scratch using Rust programming language, and input-output support. It has first-class support for local storage, cloud storage, and database, and it has an initiative API. So the API of Polars, it is so beautiful, you will fall in love the moment you start using Polars. So it is too good. And out of core, so streaming APIs, they are supported out of core. So you have this parallel work with parallel systems are also supported by Polars. And since we are using Apache Arrow in Polars, so vectorized query engine is also part of Polars. So now if you ask, what's the philosophy behind Polars? So the first and foremost philosophy is, the library has to use all the cores of your machine in an optimum way. So if you take pandas, even if I have 4 cores in my machine, I will not be able to use all the 4 cores. Okay, I'll be using just only 1 core. But when it comes to Polars, I can optimize and use all the 4 cores of my machine. That is how Polars works. And then optimizers and queries to reduce unneeded memory or work allocations. And Polars, it handles a data set larger than the RAM that is available in your system. And the API, as I told you, it's very beautiful. You'll fall in love, and it is consistent and it is predictable. It's almost like English language. So whatever the English words that you use in your daily life, the same words are used for designing the APIs. And Polars, it adheres to a strict schema, and it has been written in Rust, and it gives performance on par with C++. Okay, so let's keep all the theory aside and gets back to the coding stuff here. So just have a look at the data set that I am generating here. So this is how the data frame is generated. So first I will be importing this Polars library. I have already installed Polars library in my system. So I'll be importing the Polars as PL. So PL is the shortcut for Polars. I do not want to type so many letters. So I will just use PL for indicating the library that I'm using. And then there is NumPy library and datetime library. So here I'm coming up with a few columns. So I have an integer column. For the integer column, I have given the column name as integer. And then I have this date column, for that which I have given the name as date. And for the float column, I have given the column name itself as float. And for the string column, I have given the name as string column. So now once I execute and I display the data frame, so it looks something like this. So this is more or less equivalent to what you see in your Excel sheet. So there's nothing much difference between the Excel sheet row and columns and the data frame row and columns in Polars. So see, as I told you, all of these are in-memory data. Okay, so the moment I close this laptop, or the moment I close or exit from this IDE, from this editor, what happens is the data that gets generated here, so it will be lost. So how to store that? So for that, I will be storing the data in a CSV file like this. And for that, we have something called, this is the function that I will be using, right? CSV. It's so simple. So whatever the data frame data I have, so I will be writing it to a file called output.csv. So am I getting that data? See here. Yes, I have this output.csv. So as you can see here, so the output, whatever the output that gets generated, like integer, day, float, string. So all of this, it has been stored here in the CSV file, which I have here. And then if you want to read back the data which you have written onto the disk, then again, you can use another function or a method called read CSV. So it's again, it's a normal English. So for writing the data as in the CSV format, use this method called write_CSV. And for reading the data from the CSV file, again, use this method called read_CSV. It's as simple as that. So in Polars, it has 4 pillars, something called select, filter, with columns, and group by. So you can do anything Pandas does, the same thing with any of these 4 expressions. So you need to stitch these expressions with some other functions or methods, and you can get the data and you can perform the analysis for whatever the data that you have. So now let us see how each of these expressions are used in Polars. So please keep it in mind that you do not have these kind of expressions in Pandas. Okay, so these expressions are unique only to the Polars world. So say for example, I want to read the data from all the columns in the data frame. So I will just use this particular method called COL. Okay, and I'll specify this symbol asterisk for reading all the columns in the data frame. So see here. So this is the data frame I have defined, and the first column, the column name header is A, and the second column header is B, and the third column header is C, and the fourth column header is D. And the first column header The first column is of type integer, the second column is of type data time, and the third column is of type float, and the fourth column is of type string. And everything is indicated here itself. And this is the kind of output that I will get. So now, if I want to select all the columns in one shot, then I need to specify any of these expressions. Since I want to select the columns, I will choose this first expression called select. So using select, I need to specify which are the columns. So I will use something called this COL method that has been specified in the PL library. So it looks something like this: pl.call of star, so or asterisk. So it selects all the columns that has been specified here. Now, if you ask, no, I don't want to select all the columns which are there in the data frame, I want to select just one or two of the columns, then you can do something like this. You just need to specify the particular columns which you are interested in. I am interested in column A and column B, which are separated by a comma. And obviously, you get the output like this. So this is the output of column A, and this is the output of column B. And sometimes just selection doesn't make any sense. I want to filter the data based on some condition. So how to specify those conditions? For that, if you want to filter the data, then you have to use another expression called filter. So here what I'm doing is I am specifying that I want to work on this particular column called B, and I want to select the date and time, date that is between 3/1/2025 and 10/1/2025. So if there are any dates between 3/1/2025 and 10/1/2025 in the column B, so display all those values. So this is the output that I get. And this is a very simple way of filtering the data. What if you want to include multiple filter, a little bit more complex filter? See here, I am specifying multiple conditions here. So for the first condition is I am selecting column A and its value should be less than or equal to 3. And this is the AND symbol. And I'm also specifying that in column D, there should not be any null value. If both of these conditions are true, then display the values. So this is the output that I get. And we looked at selecting the data, and we also looked at filtering the data. So now let's move on to the next one. See, in many of the cases, we can't just work with the existing columns, right? So as I told you, sometimes you may need to add some of the columns, or you may even need to delete the columns. So how do you handle this column stuff? So for that, you have something called with columns. So if you want to introduce new columns for the data frame, whichever that you have generated, then you need to use with columns. As you can see here, so I'm summing up all the values that are there in the C column. And then for that, I will be adding plus 42. So this is one way. And I will be renaming that column as C plus 42. So as you can see here, so I will be adding 42 for each of the values that I have here. 42 plus 4, 46, so 42 plus 5. Can you see, sir? Basaraja, sir? Can you hear me? Anyone can
So
respond?
we are able to hear you.
Okay, thank you. Oh, so this is how with columns will work. And then sometimes you want to aggregate the data. So you want to see what is happening, how to aggregate. Maybe you want to find the mean value, you want to find the median value, or you want to count the repetition of the values. So for that, you have something called group by. Okay. So here, just look at the data which I have here. So I'm having two columns. One is X column and another one is Y column. And if I am interested in how many times each of these values have been repeated, then I can use this particular expression called group by. So group by Y, maintain order, and find the length of each of these different values that have been expressed in this particular column. So A appears 3 times, B appears 2 times, C appears once, and X appears twice. So this is how group by works. And You can also use group by for making a little bit more aggregate kind of computation. Say, for example, you can use group by on Y column, and you can aggregate by counting the number of columns that you can count the values, you can sum up the values. So you can do all of these things using the different aggregate functions like count and sum. And not only this, sometimes you want to combine the values from different columns and different columns that is there in the data frame. For that, you can again use with columns. So as you can see here, I'll be using column A. I'll be using the values of column A, and I will be multiplying those values with the values that is present in column C. So PL.COL of A into PL.COL of C. So I'll be multiplying these two columns, and then I'll be creating a third column for which I have named it as A into C. So this alias is used to rename the another column which I will be adding. And I will be excluding the columns called B and D. So as you can see here, 4 into 1, 4, 5 2s are 10, 6 3s are 18. So I'll be excluding these two columns which are there in the data frame, and I'm concentrating only on these two columns, that is A column and C column. And I'm doing some function on that, some manipulation, and then I'm creating a new column, and I'm dumping the data by renaming it sum. And so that is how it works. And when it comes to combining the data frames, there are two ways of combining. See, there will be this always happens in real world. So you can't always work with a single data frame. You need to work with multiple data frames, right? So for that, you have two options. One is to join. So here the join operation works in the same way that you may have experience with the.
Sorry to disturb you. How much it will take time?
Another 2 minutes, sir. That's all.
Please wait up.
Okay. Oh, so this is the join operation which we have. And another one is concat operation. That is, you can stack one data frame or another data frame, just as you can see here. And apart from this, when it comes to visualization, I have also I just extracted the Adani Enterprise data, because Adani Enterprise is something which is in use for various reasons. So I wanted to see what is happening with this data. Okay, so I extracted the high and low of their share prices, and this is how it looks. See, in 2021 its share value was like around 192 rupees, and by the time of 2022 it reached to 4,073 rupees. But due to Heidenberg report, so obviously the stock price, it fell from 4,000 rupees to 1,000 rupees. And now again from 2023 to the present 2024, the data again, the price is been rising. So this is a typical case like how we can analyze the data using Polar software and the other software called Plotly. So I have generated this library using Plotly. So this is about data analytics, and if you have any queries, I'm open for that, and you can ask me. So I like to thank Dr. T.G. Basavaju, sir. He's my mentor, my guide, and thank you very much, sir, for giving me an opportunity to share my knowledge. And I also thank the team of AROHAN for giving me an opportunity for sharing my knowledge. Thank you all. And if you have any questions, you can shoot at me. I can answer those.
Hello.
Sir.
Any question from audience? Okay, Gaurashankar, thank you very much, Gaurashankar, for your
Thank you, sir. Thank you very much.
thoughtful session. Yeah, I will invite the next speaker, Dr. Magundappa Venal, the principal in charge of Government Engineering College, Talkare, to deliver his session. So I can share your PPT.
Yes.
You can continue. Thank you.
Yes, sir. Thank you, sir. Screen is visible, sir. Hello. 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 Am I audible?
Yes, sir. Yes, sir. Your audible screen is also visible, sir. You can start.
Thank you, madam. Thank you. Good evening, respected higher authorities, organizing team members of AROHAN 2024, and different cadres of teaching fraternity. Today, I'm going to talk on role of futuristic materials and its challenges. New materials are necessary for a variety of reasons, including sustainability, resource scarcity, and technological advancement. New materials can help with sustainability and resource scarcity. For example, fungal foam is a biodegradable, water resistant, and insulating material that can be used for packaging also. Material science drives the technological innovations by developing new materials with enhanced properties, enabling the creation of more efficient and advanced technologies in fields such as electronics, transportation, energy, and healthcare. To successfully promote new material usage or replacements, material science expertise is highly valuable across industries and markets. In the material science field, the composition, structure, and property of materials are studied. This field has shaped the development of civilizations as they evolve from using wood to uh, metals, glass, plastics, and other materials. Industries and consumer expectations change over time. We used to define material usage mainly based on its functionality, properties, appearance, and accessibility. But nowadays, new creation is coming into play, a material's carbon footprint, which is increasing in importance in selecting materials. In the development and evolution of materials, we sometimes make the same material better and other times replace one after the another. Recycled and bio-based plastics are replacing fossil-based plastics. This allows plastic circularity in which waste is reduced while maintaining the functionality and benefits of plastics. Plastics are being used to replace metals for automotive parts, so vehicles and lighter overall, thus traveling further with the same amount of fuel. Acrylic plastics are used a glass replacement. These plastics still provide transparency but are higher and safer when breakage occurs. Now I'm going to talk on the smart materials based on metallic materials. Smart material is one whose electrical, mechanical, or acoustic properties, composition, or functions changes in a specified manner in response to some stimulus from the environment, which may be structural, physical, or a functional. Without design, most of the material changes its dimensions or properties when heated or cooled. What makes the smart is design the materials such that changes occurs in a distinctly specified manner to accomplish another objectives. So, based on these smart materials, we can create the smart structures. So, by embedding the sensors and actuators at the desired location inside the structure without affecting the structural integrity of the main structure. They have the ability to sense any disturbance, process this information, and evoke reaction through actuators, possibly to negate the effect of the original disturbance. These are named as the responsive materials. So how the smart structure builds? So these are the blocks for building a smart structure. These do have the control, sensor, actuators. And in between that, we can use the data transmission like a data bus bar 1, data instructions, and sensing the same. So this uh, entire building is a structure of smart material. So here, the purpose of various components of smart systems, how it relates with biological systems of a human being. So sensor, it is a tactile sensing in a biological system. So the purpose of this is to have the data acquisition, that is collecting the required raw data needed for appropriate sensing and monitoring. So in between this control system and the sensor, there is a data bus 1. So that is related to the biological systems, that is sensory nerves. So that is also used for data transmission. Coming to the another block of the smart system is a control system, which acts like a brain of a biological system. So the purpose of that is command and control the unit. So in between the control system and the actuator, there is a system that is data bus bar 2, so which acts like a motor nerves. So again, that is used for data instructions, which transmits the decisions and the associated instructions to the members of the structure. Actuator, it acts like a muscles. So here, this takes action by triggering between the devices. So as I said, the smart system is one which evaluates the external stimuli and takes some action. This action may be to neutralize the effects of the external stimuli or to perform a completely different function. In the current research, the smart systems aims at the developing adaptive, self-repairing materials and structures that can arrest dynamic crack propagation, which are heal cracks, means healing the cracks, restore structural integrity and stiffness, and also reconfiguration of themselves. So the basic requirements of this smart system are monitor the environmental and internal conditions, process the sensed data according to an integral algorithm, decide whether to act based on the condition monitored, implement a required action, and the last requirement of the smart system is repeat the steps continuously or as required. So here the structure, so which is having sensors and actuators, and together do have the controlling unit in between these two. So here the commercial status of the materials, SMAs, that is shape memory alloys. So this is a type of smart material. So example of that is nitinol. So here the material types are polymers, conducting gels, piezoelectric. Come to ceramic materials. Under this, piezoelectric, electrostrictive, magnetostrictive, fiber optic sensor systems. So these are few materials and examples are shown in the short forms here, right side. And the user development, that is material type is chromogenic materials and systems, under which the thermochromic material, electrochromic material, and controllable fluids like electrorheological material, magnetorheological material, and biometric polymers gels also be used as smart materials. So here the applications of smart materials comes here, a civil structure. In that, the smart materials are self-healing, health monitoring, and warning of the buildings. And next application in the aerostructure, that is shape aerodynamic controls are the smart materials. And coming to the medical field, drug delivery, in that also we are using the smart materials, telesurgery, and vibration and noise control. So in that we are using dampers, wallpapers, stealths. And in the area of automotive, we can see the airbags, a clutch, shock absorber, and the space structure. In that we use some adaptive structures. How this shape memory effect happened, that is, we say the origin of shape memory effect. So in that, martensitic phase transformation takes place that occurs as a result of stress or temperature change. So here the shape memory alloys, this shape memory alloy is the material that can remember its original shape. It's a class of smart material. This SMA also exhibits superelastic behavior, that we say pseudoelastic also. So the triggers for martensitic transformation are two criteria. That is, one is stress, another one is temperature. So here, as I said, the martensitic transformation, you can see the twinned martensitic, this one structure here. So these atoms are twinned here. When it gets deformed after subjecting to the load, this martensitic is converted into the again martensitic, which is in deformed shape. When it is subjected to heat, you are going to see the systematic arrangements of the atoms, that is called austenitic phase. And again, when it is cooled, then you can see the martensitic twinned structure. So this is what the remember of its original shape when it is subjected to cooling effect. So steps of using an SMA. So here I can say the different steps how to create or produce the shape memory alloys. That is betattizing. It means heating to equilibrate at the austenitic phase field of the phase diagram, pinch to form the martensite and deform the martensite, and heat to return to the austenitic phase and to restore the original shape by cooling. So this martensitic transformation, a diffusionless solid state phase, no change in the composition, also known as athermal or displacive transformations. Transformation results in a martensitic phase known as a martensite. The growth rate is so high that nucleation becomes the rate cooling controlling step. So here, as I was mentioning, the phase diagram. So it is lead and tin. You can see the temperatures of the lead at the left side and the temperature on the right side of the tin. So here you can see the melting point of the lead, which is more than 300, and melting point of the tin, which is more than 450 degree Fahrenheit. So here, this is what the equilibrate state. So at this, you can see the alpha phase, liquid phase, and this is beta phase. And the neighboring phases are mixture of this alpha and beta. And the neighboring liquid and beta in between that, it is beta and liquid. And here, in between this, the alpha phase and the beta phase below this equilibrium temperature. So here you can see when you see the microstructure of the material, you can see the phases of this material, that is 18.3% of tin, and here these phases, alpha beta phases, this is 97.8. So martensite has a twinned microstructure, as I said. So twinning enables the plastic deformation. Hence, we see the superelasticity of the material. So you can see the twinning region here. This is twinned. The atoms are in between the body-centered cubic structure, and when it is this one subjected to another process, again you can see the austenitic phase. So this phase is what twinned boundary. And background of this, so first record of shape memory transformation was found in 1932 with this AU and cadmium. So shape memory effect was discovered in nickel titanium at the Naval Ordnance Laboratory. So this is a sat form of this nickel titanium Naval Ordnance Laboratory. So here you can just see the shape of the material when it changes its shape with the help of heating, loading, and cooling. So in between that, you are going to get these phases of the material. So here, this is the atomic structure of titanium and nitinol. So here, nickel, so body centered. So it is in austenitic phase. You are seeing the cubic, it looks like a cubic centered the structure, and when it is subjected to cooling, you are going to get this haphazard arrangement of the atoms, which is called the martensite. So superelastic behavior deformed above the critical temperature show a large reversible elastic deformation. That is, recoverable strains in this is up to 10%, which is much exceeding the elasticity. Hence, the name is superelastic behavior as a result of stress induced in the martensitic transformation. That is, when it is subjected to a load. So here, heating and cooling, in between that, you are going to get a phase called the hysteresis. That is, the temperature range for the martensite and austenite transformation is greater than the reverse transformation upon cooling. That is, the temperature of heating and the temperature of cooling, that is what the hysteresis. The difference between the transition temperature upon heating and cooling is called the hysteresis. Hysteresis is generally defined as the difference between the temperature at which the material is 50% transformed to austenite upon heating and 50% transformed to martensitic phase upon cooling. This difference can be up to 20 to 30 degrees Celsius. Two-way shape memory alloys, that is, the ability of shape memory alloy to recover a preset shape upon heating above its transformation temperature and return to an alternate shape upon cooling is known as two-way memory. That is, two-way shape memory alloys. Two-way memory is unique in that the material remembers different high temperature and low temperature shapes. It has triggered many ideas in the minds of product designers. Some examples of these potential applications include reversible fasteners, temperature sensitive actuators, retrievable medical implants, toys, and novelty items. Superelasticity, these are, as I said, it is a unique material, also show a behavior if deformed at a temperature which is slightly above their transformation. This effect is caused by the stress-induced formation of some martensite above its normal temperature. Because it has been formed above its normal temperature, the martensite reverts immediately to undeformed austenite as soon as the stress is removed. This process provides a very springy, rubber-like elasticity in these alloys. Hence, the name is superelasticity. So, setting shapes to shape memory alloys. How to produce? The use of shape memory or superelastic element for a particular application generally requires the setting of a custom shape in a piece of shape memory alloys. The process required to set the shape is similar whether beginning with SMA in the form of wire, ribbon, strip, sheet, tubing, or bar. These will be discussed later, how these will affect in this SMA. Shape setting, that is called training, technical name, is accomplished by constraining the SMA element on a mandrel or fixture of the desired shape and applying an appropriate heat treatment. The heat treatment methods used to set shapes in both shape memory and superelastic forms of SMA are both are similar. So what are shape memory alloys then? So as I said, there's a phase transformation between martensite and austenite between the process of heating and cooling when it is subjected to a load. Shape memory alloys are metallic alloys that undergo a solid to solid phase transformation which can exhibit large recoverable strains. That then only we can say it remembers its shape. So example same, that is nitinol material and then copper, aluminum, nickel, etc. So here again, when it is subjected to a temperature, the phase transformation means the finish of martensite, the start of martensite we can see, finish of austenite and start of austenite we can see in the process. So this is a transformation of phases with the example of the spring subjected to a load based on the heating and cooling, and this we can see the atomic structure of the material of any alloys. And this is just a pseudoelastic effect of shape memory alloys. With the help of the wire, we can see the sudden changes of this wire into its original shape when it is subjected to heating and cooling effect. So here some of the manufacturing methods, this I am not covering. Advantages and drawbacks in use of the SMA actuation mechanisms. Some of the advantages are its simplicity and compactness and safety of the mechanism, power to weight ratio, and drawbacks are low energy efficiencies. Means in the starting, its actuation is slow, limited bandwidth due to heating and cooling. So this is what a big challenge for the uh, engineers or designers. Degradation and fatigue of the materials after continuous usage of the materials. Means the controlling of this is very complex, so you have to go for a new material which is not the economical. So where are these SMAs are used? So first we can see the medical applications, that is dental arch wires, microsurgical instruments, micro grippers, blood clot filters, guide wires, and catheters. So lot of applications we can find these SMAs in the medical field. In aerospace and military applications, like non-explosive release systems, a fine tuning of helicopter blades, electrical connectors. Coming to the automotive applications, fan clutch, springs, hydraulic systems, and sealing plugs. And if you see the applications of these SMAs in industrial applications, that is MEMS, microelectromechanical systems, and sprinkler systems, valves, and gas turbine blades. So here we can see the major applications in the advanced field like nanomuscles and surgical instruments, tissue spreader, stents, coronary probes. You can see the sketches of these, and brain spatula. And in endoscopy also we can see the miniature size of the device. That is, we can zoom and see the defects in the parts. Bending actuators and force sensors, smart skins, that is wing turbulence reduction. So this is what the example of biomedical applications, that is the superelasticity nature of the nitinol appears to much more psychological compared to the stainless steel. For example, you can see the hysteresis curves. So out of these materials, we can see the best suitable, the hysteresis curve for this is the nickel and titanium. So the revolutionary life of the SMAs you can see by the applications of these materials in the medical fields, robotic arms, bone anchors, in spinal cord disease and all. We can use this, and the this one, wires for dentists. So these are all major applications of these shape memory alloys. So this is what the coupling for tubing, use of memory alloys, that is shape memory alloys for coupling a tubing. Here you can see the original diameter of this tube. When it is subjected to heating, we can see the expansion of this. It should be designed for particular temperature. What should be the diameter of the increase in this one? It depends on the material. whether you are using copper, aluminum, and nickel. So separately or this in a alloyed form. So when it is expanded, so we can see the insertion of this tubing on this tube, and you can go for squeezing also. When you go for squeezing, we can go to the step, means lesser than this original diameter of the tube. So how to contribute to smart structure? So here, the transformation between martensite and austenite, sensing and actuation, control of structures, shape memory, damping, stiffness, promoter for the ideas of adaptive wings, hinge-free solar panels, and robot arms. So recent SMA applications for transportation, we can see these shape memory alloys rings are used as a clamping for holding the drill bit of a drilling machine. So this is what the SMA ring we can see, the application of this. And this sketch is what the shape memory alloys spring to control the wall. So these are the two walls, opening and closing of this. So this is what the shape memory spring, that is alloys are used in the form of a spring, and this is what steel springs, and it is used as a dummy effect, but the major working of this is shape memory springs. Based on the pressure, it just actuates, or it just moves, or it just compresses or expanded, and by that the operation, it just closes and opens the apertures here. So smart structure ideas using SMA. What is a smart? That we can see from the aerodynamic profiles here, and this can be changed into a different lengths and this one angles of bending by the application of heating the materials. So these are all different applications we can see in rotorcraft, in antennas, etc. So here we are using the adaptive transport wing concept. So these are the challenges what we have here for shape memory alloys. Increase in complexity, describing the constitutive behavior. Just with these two examples, I will end my speech. So here, this one is Brinson's model, and these small dots are the experimental. So here, this this one experiment values, we supposed to get the graphs to this Brinson's model. So that is the challenge for the engineers or designers. So this can be drawn with the help of drawing the curves with the values of stress and strains of the materials. And here also, this is what comparison between the experiment and analytics. So here, the gray lines, we can see these are the gray lines, and black dashed lines we can see. We need to approach these gray lines, then we can get the effectiveness of the shape memory alloys. With this, I conclude my talk, and any questions, please. Hello. 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 Audible? Basuraj?
Hello. ಹೇಳಿ ಹೇಳಿ
Ha,
ಮುಗಿತಾ?
sir. Ha, yes, sir.
Any questions from audience? So I think there is no questions, sir. So thank you very much for session. Wonderful presentation.
Thank you, sir.
Thank you for your I made a last minute request. Despite of your busy schedule, taking care of our college work.
Yes, sir.
That's
Yes,
our
sir.
request. Thank you very much once again. On
And
behalf of the officials of Collegiate and Technical Education and all the audience here, I wholeheartedly thank you for giving a wonderful session. So thank you very much, session. Thank you very much, sir. So
Thank you.
yes, actually we have come to the end of session. Gavai, do you have any questions?
yes, sir.
Gavai raise ಮಾಡಿದ್ದಾರೆ. Sir, you can unmute and you can ask the question.
Yes, sir. ಕೇಳಿ ಸರ್.
ಇಲ್ಲ ಬಿಡಿ ರೈಸ್ ಮಾಡಿದಾರೆ ಅಷ್ಟೇ, ಏನು ಮಾಡ್ತಾ ಇಲ್ಲ. ಇಲ್ಲಿ ಬಿಡಿ ಸರ್, ತೊಂದರೆ ಇಲ್ಲ. ಐ ಥಿಂಕ್
Right, sir.
ಯಾ ಥ್ಯಾಂಕ್ ಯು ವೆರಿ ಮಚ್ ಸರ್.
Thank you so much, sir.
ಓಕೆ, ಥ್ಯಾಂಕ್ ಯು.